So let's go into that part. So first we introduce what's the meaning of voice over IP. Let us suppose if there are two systems connected through routers in the middle, and if there is some voice getting generated on one computer, um, if we need to send this voice to the other computer, typically by using IP network, we can call that as a voice over IP. So pack the data in the form of a digital format and send the data on an IP network. If you can do that, that can be equated to voice over IP. So for example, if you have a application that is installed on this computer, which is reading the human voice and converting that into digital information by using some coding techniques, let us suppose. And after converting it into the digital data, what do? We um, encrypt the data with the presentation layer so that nobody else will be able to hear that. And then in the session layer, we are having um, time domain information added in the session layer, um, like what is the ongoing time right now, the live time related parameters will be added so that we can verify on the receiving side whether this packet is delayed or not delayed. So as usual, transport layer will attach the port numbers, and network layer will attach the source IP address and destination IP address. Source IP address is going to be this computer, destination IP address is going to be the other computer. And with the help of the data link layer and physical layer, if you transmit the data to the next router, routers will start forwarding this IP packet towards the destination. So obviously, the destination system receives the data link layer frames, and um, you know once the IP packet is delivered, the network layer on the receiving system um, remove the IP layer header and sends the transport data to transport layer. Transport layer, with the help of the port numbers, it will identify the data must be sent to which application, and then once we forward this to session layer will validate whether the voice data is received within the time or not, like is it delayed or not. It will verify those things. After that verification, the data will be forwarded further, like to presentation layer to decrypt the voice data into normal format from the encryption format. And once we give the data to application, which converts the digital data back into the analog format and play it for the human being who is listening on the other side. So typically this is your voice over IP concept, voice over IP mechanism. Now, if this is voice over IP, um, so what are the other flavors that we can have in this voice over IP mechanism? Is this the only flavor that we have, or
Is the only flavor that
do
we
we have any other flavors? For example, if we are um, not implementing the presentation layer, for example, what can we do is we can ignore that presentation layer part. So presentation layer will not be present. So we voice over IP without the security. So obviously it leaves us to question, first of all, what is the meaning of VoIP and what are its challenges? Package the voice and send the IP packets from source to destination. Now, if that is that simple, voice over IP is this simple a concept. Why do we need a lot of complexity involved there, and why do we require some complex protocols like SIP and etc. etc.? Why do we need these protocols? For example, SIP is a session initiation protocol, and we need to ask ourselves, why do we need this? What does this SIP guy do? Okay. To understand what is this SIP guy going to do, first we need to understand the problems that are involved with VoIP. What is the biggest nightmare for VoIP? Now, the biggest problem is how the VoIP caller system finds out the IP address of the VoIP callee system. How do you find out? What is the IP address of the destination system? This is the biggest problem that we are going to have. This is the biggest issue that we are going to have. Why the IP address finding is a issue? What is the trouble with the IP address? In case if you want to find out the IP address of a server like a google.com or facebook.com, etc., etc., you have to find it out with the help of the DNS servers, DNS mechanism. We have to find it out with that. But the biggest problem with the VoIP users is VoIP users will be moving from place to place, and their IP addresses might keep getting changed. So when there is a dynamic IP address, every time storing the dynamic IP address in a DNS server is not a good idea. Reason is DNS servers will not be able to dynamically change and report the dynamically changing IP addresses. They're not capable as such. The systems are not capable as such. Why? Normally, if you store any kind of a server's records in VoIP, in DNS server, it takes a lot of time for the DNS servers to communicate that information to the other DNS servers across the world. At least it will take like 24 to 48 hours. So it's a huge amount of time. That means once you change your IP address of the server to propagate it through all the DNS servers in the world, it takes a lot of time. Now, but you may be moving from one LAN to another LAN frequently, and your IP address might keep getting changed based on your present location because you're moving from one location area network to another location area network, or basically one IP network to another IP network. So, what's the issue you face? Your IP addresses keep on getting changed, so there is no way DNS kind of systems can help you out in this scenario. Then what do you need? Who needs to help you out here? That means we need to build a different architecture together for helping the VoIP systems to find out the dynamic IP addresses. So that is why establishing a VoIP call is not easy, because you need to find out your friend's computer's IP address, a live one. Every time he might move into a different network and IP address might keep getting changed. So how can we implement that kind of an environment? So what is this SIP? So SIP's initial design it is to deal with finding the dynamically changing IP addresses. That is the primary concept of SIP, Session Initiation Protocol. It has been invented just to help the systems to find out dynamically changing IP addresses of the other users. But later even though this is the primary feature they wanted to implement in SIP, later they have added some additional features also. So what are the primary SIP features? It can determine the location of the user location. User location here represents IP address. Basically, from VoIP point of view, it typically equates to IP address. Okay. Hello. Um, then what? User availability. Information on whether the user is willing to communicate or not. Just like how on your WhatsApp you can find out if somebody is online, if he is online, whether they are busy or not, they want to take the calls or not, like that kind of a willingness kind of information you can find out. So that is user availability. So even that information also can be updated by using SIP. And at the time of making the call, carry third-party multimedia session properties. Like what kind of a multimedia call that you wanted to make with what multimedia properties. So you can exchange those details as well. Like what kind of audio codec you want to use, and what kind of a video codec you want to use if you are making a live video call by using SIP. So SIP can be used for making any multimedia session. So by exchanging these kind of third-party parameters, like multimedia properties for the session, you will be setting up the session. So session setup. After the session setup, you have to maintain that session. You have to maintain the session because again the user might be changing from one location to another location, and um, you have to do the session maintenance with the changing parameters and changing locations. For example, suddenly one user moved from one Wi-Fi network to another Wi-Fi network with a mobile phone, leaving the old network and moving into new network, IP address gets changed. So SIP need to find out that changing IP address. Maybe multimedia parameters also might get changed. Okay, like earlier you were having some X amount of quality. Maybe you want to increase the quality of your call. Okay, so it could be that. So there can be some multimedia parameters that might be changing as well. That falls into the session maintenance section. And then finally we have session termination, orderly tear down of the session, terminating the session. So even though the primary SIP functionality is to find out the location of the user, but they have added a lot of details later, like a lot of functionalities, exchanging multimedia properties and dealing with those. All right. So, what kind of a SIP protocol stacks that we will be having anywhere? So, the SIP protocol stack that we will be having is all these. For signaling of the SIP protocol messages, we'll be having SDP SIP, TLS, SSLv3 are equivalent. So, SIP is the highest application layer protocol. On top of SIP, we have something called as SDP, stands for Session Description Protocol, which will be exchanging the third-party multimedia properties. And that application data, if required, we use presentation layer, but session won't be needed at all. And then we are going to have the transport. All three options are applicable for signaling transport, TCP, UDP, or SCTP. So you have IPv4, IPv6, L2, and L1 as well. So we can use IP, data link, and physical layer. So this is the signaling part. Session layer won't be there because session layer required only for your data to note down the live information. For signaling messages, you don't need session layer. But when it comes to the voice, your voice data may be encrypted with the presentation layer. To note down the live timing related information, we might be adding RTP, and transport protocol we have to use for the voice data is UDP. We won't be using reliable protocols for voice as we don't require reliability. We have to choose an unreliable protocol over here. If it instead of voice, if you are making a multimedia session by using SIP, which is a video call. Your video data could be packed into uh, presentation layer, TLS, SSL 3 are equivalent for encrypting the video call, and then you might be having a session layer called as RTSP, real-time streaming protocol. We would be having, and then below that we might either use TCP or UDP for that video call, depending on different situations. We can choose any one of those two, TCP or UDP. To maintain something called as quality of service estimates for the VoIP calls, we use a quality of service protocol stack also, which works with a separate protocol called as RTCP, which sits on UDP IPL2L1. At IP layer, we can either have IPv4 or IPv6 and L2L1. So any VoIP application for making the calls and to deal with the servers and to communicate with the components, we use signaling. That is this part. So to send the voice or video, we will be using these protocol stacks. For the voice call or for the voice call especially, if you wanted to estimate the achieving quality of service, in order to do those QoS estimates, you will be using this RTCP and UDP protocol. Okay, so IPv4 and L2, L1, etc. All right. Um, anyway, we'll be learning all these protocols one by one. So we will be learning them and understanding their concepts. So just a protocol stack introduction as is. Okay. Um, Now there are two kinds of VoIP environments that are possible in the world. One is a private VoIP environment. The other one is a SIP-based VoIP environment. And the first one we are introducing is a private VoIP environment. So what's the meaning of private VoIP environment? Private operators who are maintaining these VoIP networks. For example, you can take WhatsApp or Skype or somebody. So these are all called as private VoIP environments. So you have internet, you have lot of computers where the private applications are installed. Okay, like you can take it as a Skype, for example. So there are six users on six computers, maybe. They have logged in with their usernames and passwords. They'll all be connected to internet. They will be communicating with this server, the private VoIP server. If it is Skype application, you will all be communicating with the Skype server. If it is WhatsApp application, you will be communicating with the WhatsApp server. So you would be performing that. So this is actually called as a centralized VoIP concept, where all n number of VoIP clients will be registering with one register. What do they register with? What is the meaning of registration here? They have to register their live IP address. They have to communicate their live IP address. All these VoIP clients. So these VoIP clients will be able to detect who is acting as your central register um, with the help of DNS servers. They can go and communicate with the VoIP uh, central register and explain the register that, hey, I am so and so person, and my IP address is so and so. Okay, my ID is this, my IP address is this. So you will be notifying it. So there are six customers, there are six IDs, just like you have a Skype ID. I have just put ID1 to ID6. I did not write it, I did not write any proper IDs there, simply kept some notation there and their corresponding IP addresses. So it's a central database. And every time a user moves from one network to another network and change of the IP address, they will know that they have to immediately speak to the central component and update their present IP address in place of the old IP address. So you have to keep updating your IP address. So all the VoIP environments work on this concept. So your mobile, if it is having a WhatsApp also, it will be working on the same concept. It will be updating its IP address to WhatsApp server. This is my present IP address. Okay, so that is that. And if anybody wanted to make a call to anybody else, they have to go to the centralized server. For example, if this fellow want to make a call to this fellow on the VoIP application, so what happens? This guy makes a call on the basis of the ID. For example, ID 5. The call details would come to the server, and the server finds out that the ID 5, the user with this ID 5, is available at 5.6.7.8, and you will start sending that call related information to the other user. So this is centralized VoIP environment. In centralized VoIP environment, you will be using a private protocol for communication between the components and servers, or servers to components. Which protocol we will be using? Is it the SIP or is it any other protocol? No, we won't be using the SIP protocol. We will be using some other protocol. So which protocol is that? What is that some other protocol means, and what is that? What is that protocol we use? Um, it is proprietary protocols. Skype uses their own protocol for communication between the components. WhatsApp uses their own protocol. Google uses their own protocol. Facebook uses their own protocol. So there is no standard mechanism for these companies. So they'll be using their own privately developed and proprietary protocols for communication between their clients to the server. So the biggest difficulty with this centralized VoIP with private VoIP environment is only these customers can call themselves with each other. For example, if this guy wanted to make a call, let us suppose that this is a WhatsApp server. If this fellow wanted to make a call to Facebook user who is having a Facebook ID, now that is not possible. That call is not possible because this server don't know where a Facebook user is registered and what is its IP address. That details will never be known to the WhatsApp server. He doesn't know. He says that if you are making a call to any other WhatsApp guy, I can help you out. If you are making a call to Facebook guy, how can I help you out? That Facebook ID I don't know. I won't contact Facebook. Even if we contact Facebook, Facebook won't provide any such information to us because mostly they will fear about the information being stolen between one company to another company. Companies will never coordinate with each other. So each one is an independent private environment. There is no kind of inter operator calls that are possible. Only WhatsApp users can make calls to WhatsApp users. Skype users can make calls to Skype users, etc., etc. So it is a restricted environment. But when you take our actual um, our telecommunication calls, you can make a call to anybody in the world. If the person is present in any telecom network in the world, you can make a call. There is no problem at all with that. But that kind of a possibility won't be there here. Okay. So your IEEE and IETF companies or IETF organizations, they have found out that hey, these private VoIP environments are not so good for the worldwide implementation to be able to be assembling all the user services together and make a call from anywhere to anywhere. That is not possible in VoIP environments. So what do we have to do? We have to build an unified network where even if multiple companies are integrating together, we must be able to serve those users in a unified way. They should not be independent systems. Um, and they implemented the corresponding mechanism. So what they did. So they have developed a new protocol called as SIP protocol, RFC 3261. So RFC is a IANA document in which they have derived the first SIP. Of course, they have derived the SIP with previous RFCs also, but those have become obsolete. And this is the present RFC, that is applicable for SIP RFC 3261. In that they have developed SIP. So how the SIP environment will be different when you compare with the private centralized VoIP environments that we have studied just now? How it would be different? So in case of SIP, we have first we need to understand something called as terminology. So we'll have something called as user agents in SIP. All the systems that are enabling the calls, initiating the calls, and receiving the calls are called as user agents. And we have user agent clients and user agent servers. User agent clients are the ones who are initiating the requests, and user agent servers are the ones who are receiving the requests or accepting the requests. Okay. Then what are the servers we have? It is not a single centralized server concept that we use in SIP environment. So there are multiple servers for various purposes. But what are they? Um, there's something called as a proxy server. Duty of the proxy server is to help forwarding the client request towards the server here in the sense user agent server. It helps forwarding the client request, this proxy server. Redirect server, if he receives any SIP message, it is going to tell you the details about how to reach the destination. It will not forward himself. He will come back to you, and he will be providing you. It will be providing you helpful information. It will be telling you that you have to go to so and so guy, and they will help you out. So that is the redirect server. We have a register server. Um, the registers user agents and find out their IP addresses. So to store the information, the live information of the users to be able to make the voice over IP calls. Location server is something which finds the location of the user by requesting the details from the register, asking the register that, hey, can you please tell me what is the IP address of this particular fellow? I want to send a call to him. Please tell me that. So if anybody does that activity, that's called as location server. Proxy location register servers are defined in the above thing that are defined are logical entities. Implementation may be different from company to company and organization to organization. We can we can define all these components in a single hardware, or we can separate them with multiple different hardwares. We can do that. When it comes to these servers, we can have a single hardware component which is containing a proxy, redirect, register, plus location server all together. So we can do that. And the word the terminology gateway is used whenever we are trying to make a call to external VoIP technology systems like your PLMN or PSTN. If you are making the calls, the connecting component towards the PSTN and PLMN with ISDN networks is called as a gateway. So gateway, we have to consider that it is the external component. This gateway is. All right. Um, we have to learn more. This is just an introductory slide of these components. We see the environment, how it looks like. So this is the typical SIP environment, SIP architecture. So there is a originating user agent. There is a terminating user agent. Terminating is the incoming receiving guy. Originating is the call originator guy. So you have an outbound proxy, you have an inbound proxy. We have registers, etc., etc. All the components. But first things first. In the SIP architecture, there will be something called as domains. Domain typically represents, it could be a company that is providing you a SIP service. It would be a company, or it would be any organization which is providing the SIP services. So there can be n number of companies who have registered with IANA, Internet Association for Number Assignments, and they can get a SIP domain. For example, at the right of wipro.com can be a SIP domain. Okay, so they can have their own SIP devices to make the calls to the other SIP devices. But at the rate of wipro.com is the domain network ID, basically, as simple as that. So every company will have their own uh, registers to register the user's IP addresses. For example, this fellow would have already registered with the register explaining him that my IP address is so and so. So this company, this is one company. Let us take this could be one other company. So there could be multiple companies, both belongs to maybe two different networks. So when this guy registers the IP address with the register, what happens now? Register notes it down and keeps the information with him. Hey, so and so user with this so and so ID registered with me, reported me his IP address. I'll keep it. When this guy originates a call, this guy is going to use his ID as the source ID, and this fellow's ID is going to be the destination ID. And this guy don't know the IP address of the terminating user. You don't know the IP address. Your duty is only to forward that SIP call to your company's outbound proxy. So every company will be having an outbound proxy to deal with the calls, deal with the generating calls. Once this outbound proxy receives it, with the help of the source ID and the destination ID, this fellow can recognize that, okay, the call is not within the internal network, it is going outside, it is going into a different network. So what do I have to do? Um, I will have to find out the IP address of the other company's proxy server. I need to find out the IP address of the other company's proxy server. How do I find out the other company's proxy server? You go and talk to DNS server and say, hey, DNS server, can you please tell me what is the proxy server's IP address of wipro.com? Because my guy is generating a call. For example, this guy's user ID is some X at the rate of, infi.com. Okay. And he is making a call to some Y at the rate of wipro.com. So you got to know the domain name of the company. Once this information goes to outbound proxy questions the DNS server. Can you please tell me what is the incoming proxy server of wipro.com? Because this fellow is making a call to wipro.com server. So these components will have fixed IP addresses whose information is available with the DNS servers. Once you find out the IP address of the Wipro.com's incoming proxy IP address details, then you will forward the call to this particular system, this particular proxy. This proxy says, okay, I have received a call from so and so person to so and so guy. Now I need to find out what is the IP address with which it is registered. It will be acting like a location server. It will be going and requesting it from a location server, or he himself can be acting as a location server. And that location server talks to register, ask him, hey, what is the IP address of so and so person with some person Y at the rate of wipro.com? What is his IP address? This guy replies back. This guy gets to know the IP address. With the help of IP address, that SIP call details will be sent to the terminating user agent. So ultimately, if there are, let us suppose that worldwide there are 10,000 companies who are maintaining the SIP services, our VoIP SIP services. All these 10,000 companies will have domain names. 10,000 domain names will be there. For each network, there will be a register, there will be a proxy server, there will be a location server, and all these components will be common for every network. So, um, incoming calls always will arrive at your proxy. Proxy will question the register directly or indirectly, and it will be gathering the IP address details of the destination user, and with the help of it, the call will be forwarded. It is not a centralized database. It is distributed databases. As I told you, if there are 10,000 companies in the world, you will be having 10,000 registers. You would be having. You will not be having a single register. You will be having 10,000 registers. So what's the idea of the SIP environment? They said that, hey, instead of maintaining one centralized database, we will maintain a separate database for every company which is providing the SIP services. And anybody who wants to make a call to any one of these organizational users, you have to send that call details to our incoming proxy. Our incoming proxy will be able to find out the details from our register and forward that SIP call to the actual user. That's the idea. But how do you find out the IP address of this incoming proxy? Every company which is maintaining a SIP network must store their proxy server's IP address details into DNS systems. So once you question the DNS server, what is the IP address of the incoming proxy of any company, you will be able to find out that IP address. From with that, you will be sending the information to the incoming proxy. That guy will question the register and get the IP address and then forward the call to terminating user agent.
Sir,
Sorry, someone is asking
any
questions.
any live example of this mechanism?
What do you mean by live example? I have told you live example, right? Like there are two SIP based users that are present, and these SIP based users that are present are interacting with each other and making a call from one system to other system on the SIP user IDs. I have just told you a live example only. Again, you repeated. I am not understanding. Okay, let us call this guy as user X at company1.com. Company1.com. This guy is user Y at company2.com. This guy has registered to register that, hey, my ID is user Y at company2.com and my IP address is 1.5.7.8, something like that. It has reported it to register. Register noted down this address. Now this guy is making a SIP outgoing call with the source ID is his ID. Destination SIP ID is user Y at company2.com, and the SIP outgoing call will reach the outbound proxy of this company one network. This is company one network. This is company two's network. So in the company's to one network, the call details will be sent to the outbound proxy over here. Okay, it will go here. Um, so what do you do when these call details are sent to outbound proxy? This guy says that, hey, the call outgoing call is making is going to user Y at company2.com. Now I don't know what is the IP address of user Y at that company2.com. I have received the SIP message, SIP outgoing call information to me. What do I do? I will first go and question DNS server, ask him that, can you please tell me where the incoming proxy server for company2.com? What is the incoming proxy server for company2.com? This guy returns back and say that the IP address is, you know, 1.5.7.100. This is the IP address of the incoming proxy server for company2.com. By finding that IP address, it will forward the call details to this SIP incoming proxy of company2.com's network. This company2.com's network, this fellow inbound proxy, it goes and questions your register, local register, ask him that we are getting an incoming call for a guy called as user Y at the company2.com. I hope you know the IP address of that fellow. Can you please let me know? This guy replies back to him and tells that that guy is present at 1.5.7.8. With the help of that, you are sending that SIP call proxy. It ask him that, can you please tell call will reach the outbound proxy of this company one network. This is company one network. This is company two's network. So in the company's one network, the call details will be sent to the outbound proxy over here. Okay, it will go here. Um, so what do you do when these call details are sent to outbound proxy? This guy says that, hey, the call outgoing call is making is going to user Y at company2.com. Now I don't know what is the IP address of user Y at that company2.com. I have received the SIP message, SIP outgoing call information to me. What do I do? I will first go and question DNS server, ask him that, can you please tell me where the incoming proxy server for company2.com? What is the incoming proxy server for company2.com? This guy returns back and say that the IP address is, you know, 1.5.7.100. This is the IP address of the incoming proxy server for company2.com. By finding that IP address, it will forward the call details to this SIP incoming proxy of company2.com's network. This company2.com's network, this fellow inbound proxy, it goes and questions your register, local register, ask him that we are getting an incoming call for a guy called as user Y at the company2.com. I hope you know the IP address of that fellow. Can you please let me know? This guy replies back to him and tells that that guy is present at 1.5.7.8. With the help of that, you are sending that SIP call related information to this guy. This guy's IP address is 1.5.7.8. Are you understanding? So at the time when this guy is originating the SIP session, when this fellow is originating the SIP session, he doesn't know what is the destination system's IP address. It doesn't know the destination system's IP.
Sir, actually, I would like to know here, sir, whether I have made this call in a daily life or not, sir.
Sorry?
WhatsApp call is related to the private network. Sir,
Hmm.
I just want to relate this uh, architecture with the call that I made on daily life. I'm not able to link that one, sir.
Okay. How many networks are present in case of in case of a private network? Is the private network connected to any other private network? Obviously, answer is no. For example, you got to know somebody's phone number. You have stored it in your mobile phone contact list. After that, you wanted to make him a WhatsApp call, but when you try to search for him on WhatsApp, it says that there is no such a guy. Because he is not installed WhatsApp and he is not registered with WhatsApp server and his address is not available on WhatsApp, you cannot make a WhatsApp call to that fellow. Okay, so every organization is a independent entity and there is no cross-connectional calling between one operator to another operator or one private VoIP environment to another private VoIP environment. Is that clear or not clear? So far, is it understood? You
That's it.
can you cannot make a call from
Yes, sir.
WhatsApp
Yes, sir.
to Google, Google to Facebook, Facebook to WhatsApp. You cannot do all these cross connection calls. Not possible because they are not having any kind of a shared database mechanism. Nothing. Okay. But when it comes to this our SIP environment, what is going to be the difference in the SIP environment? Every company, every organization is going to have their own environment. In that environment, typically, how many components will be present? You can take that there are lot of users and there also are lot of proxies and registers. So if there are a lot of users in a company, those users will be completing the registration with their local register. For example, uh, if this is company2 user, company2.com user will register with company2.com registers. Even in company1 also there will be registration server and company1 users will be registering with company1 register. So every company's user will be doing registration with their own network components. All these are like there can be 10,000 such networks. Each network is having their own devices. But here, you can make a SIP voice call from any organization user to any organization user. It is a it is not a independent private network. So it is an integrated network. You can make a SIP call to anybody in the world. Okay, so that the user may belong to any organization, doesn't matter. So you can make a SIP call to that particular user. So that's the basic idea of the SIP environment. How they are actually making it? They are keeping the network separately, and they are able to perform call connectivity from one network to another network as well by introducing a concept called proxies. You will store these proxy servers information to DNS server. So every proxy IP address will be stored into DNS server. If there are 10,000 companies in the world, all 10,000 companies proxy servers IP addresses would be stored into DNS server. Now, if anybody wanted to make a call to any of the companies, you have to find out what is the proxy server's IP address, and you will forward the call there. The proxy will go and talk to register, find out the IP address of the user, and then forward the call to the destination. Okay, I am telling you the answer, but I don't know whether you are getting the point or not. I would like to find out in what way you wanted to find out the difference between the private environment and this environment that I have explained. What is the
Sachin, sir, I got your the idea about this, sir. But
hmm.
I want to relate that one in real life, sir. Like we are making
Any
a
live
call or WhatsApp.
any live
What's
example
So
about
here,
this
can you make the
architecture?
call?
live example I cannot give you because none of you have experienced SIP environments. Most of the worldwide all famous companies will be using Vivo IP phones. Like for example, if you take any big organization like Wipro, Infosys, Microsoft, all these companies will be having SIP environments, and they will be getting the SIP environments registered with IANA, Internet Association for Number Assignments. For example, you can ask if you can actually like go and get a VoIP service by contacting BSNL, for example, or by contacting Airtel. So if you ask Airtel that I want VoIP services, Airtel will provide VoIP service to you. What do? They will be installing one VoIP phone, or if you wanted to install the VoIP service on your computer, they will assign you one VoIP ID. Your ID is going to be, for example, your name is Ram, for example. It is going to be Ram at the rate of airtel.com. This is going to be your SIP username. Okay, so Ram at the rate of airtel.com. You got it. Now, once you got it, you need to go and your computer will have a IP address. You need to go and communicate with the airtel.com's registration server that your present IP address is so and so. It could be 51.5.6.7. It could be your present IP address. You will be registering with the Airtel server that this is my IP address. If, for example, if somebody in the world is actually making a SIP call to you, they know your SIP ID. This is your SIP ID, ROM at the rate of airtel.com. So they will be making a SIP call to your device on this Vivo IP ID. What will happen now? Once the call is made by that user, the call information will go to their company's outbound proxy. What is their company? For example, the person who is calling you is from Microsoft, let us suppose. So Microsoft person who is having ID beam at the rate of Microsoft.com. That guy is the that is the SIP ID of that fellow. That guy is making a SIP call to you. The call will come to Microsoft outgoing proxy. Microsoft outgoing proxy will ask the DNS server, hey, who is this Airtel.com and where this bugger is located? Can you please tell me Airtel.com's proxy address? Once Microsoft proxy finds out Airtel.com's proxy address, the SIP call will be forwarded here to the incoming proxy of Airtel network. Once incoming proxy of the Airtel network receives it, it will question the register server, ask him that who is this Ram fellow man who is getting a SIP incoming call, Ram at the rate of Airtel.com. I want to find out if this guy's IP address. registration server will give reply back to that guy and tell that the IP address is 51.5.6.6.7. So then by using that IP address, you forward that call information to this fellow. Now, what more examples I have to give you? Because you guys have never experienced a SIP environment, you are not able to visualize, and you are asking me for live example. You need to buy a Vivo IP phone, or you would have used IP phones in companies. You would have used it. Then this makes sense for you. Otherwise, I cannot give you a practical live example that you not experienced. Is
Sir,
this clear
are those
now?
Cisco phones, sir, that are using in companies?
Okay.
Cisco hotline numbers?
Yes, Cisco phones are having Cisco is having their Vivo IP phones, but Cisco can only provide you, maybe only they can provide you their devices. Cisco is manufacturer of devices. They are not providing you maybe like a service. I don't know. Maybe they are providing service also, Vivo IP services also. If you buy the phone along with the service, your user ID is going to be somebody X at the rate of Cisco.com. That will be your user ID because you are getting their services. But if you are simply buying a Cisco device, um, Cisco phone, which is IP phone, you getting it and installing it in your company's premises. Your company is, let us suppose that you are working for TCS organization. So in TCS organization, they are using a Cisco phone. They have installed on your cubicle. So now you have to make a call to your somebody else who is having a SIP ID. So when you make a call, so your ID is going to be like your name at the rate of tcs.com, because typically TCS company will get the Vivo IP domain for themselves from IANA as at the rate of tcs.com. It looks like IP address only. Mostly these IDs will look like IP address. It's just like your Skype IDs. Your Skype ID could be simply like your Gmail address is your Skype ID. Okay, you can tell that this is my Skype ID. Who is providing the devices is not the point here. We can use the VoIP devices manufactured by anybody. It may be Cisco device, it may be anybody else. Or, as I told you, there are two kinds of Cisco user agents that we can have. What are the two types of user agents we can have? One is called as IP Vivo IP phones. Okay, so these are called as Vivo IP phones. So you can purchase these Vivo IP phones from the market, which will have the SIP protocol stack, which will have SDP protocol implemented, which will have UDP, RTP, UDP protocol stack implemented, which will have voice codecs. All the protocol stacks will be there. UDP, IP, Ethernet, physical, etc. It will be connected to a Ethernet cable. It will be having a DHCP protocol also to communicate with the nearby DHCP server and get the IP address and report that IP address to the register. This is my present IP address. So it might be having a DHCP server as well. Or you can simply install a you can simply install a VoIP software on your computer, which is a SIP-based software. Okay, so which will have, when you install that software, it will be having the SIP protocol stack present there. As simple as that. It will be present in your computer. The SIP protocol stack would be present in the computer.
Sir, these phones will be a landline phone or portable devices like mobile handset.
You can install SIP on anywhere. By now, you're not getting this idea. That means there is something wrong with, just think that SIP is a protocol mechanism. And right now, my computer is a SIP device. For example, my computer is a SIP device. Um, So how can I say that my computer is a SIP device right now? Because I have a SIP software installed on my computer. This is a SIP software. You can make SIP voice calls by using this SIP software installed on my computer. Okay, so you just dial the number, or you can add the contact details with just looks like the email IDs. You type them and you can add them and you can make a call, because my computer is having IP address, and when I install this SIP software, I will be having the SIP protocol stack installed on my computer. Rest of the protocol stack is already present in my computer. UDP software, IP software, Ethernet, and physical layer will be present. Only application layer you need to install. So SIP will get installed with this. You can install, for example, you are using a old Dabba mobile phone and buying a Reliance Jio SIM card. Now, that old Dabba mobile phone, if it is, even though it is a LTE mobile phone, it might support VoIP environment, it might not. If your phone is not having SIP protocol, what Jio people will tell you is, hey, you will go to this Google store, Play Store, download some Geo app. When you install the Geo app, SIP protocol will be installed, and you can start making the IMS calls, Vivo LTE or Vivo IMS calls. Okay, so SIP can be installed as a software also. It can be present in a hardware. If it is present in a hardware, it look like a phone, but inside that there will be a small computer running, and it will have all the protocol stacks running. SIP protocol, UDP, IP, Ethernet, physical, everything. All these protocols will be present inside this small computer that is built for making the phone calls. It looks like a phone. Okay. So how many types of
But
phones?
P-
Yes.
so,
Yeah.
but PBX is the software like the PBX phone or something.
PBX is
What
your
else?
proxies actually. Okay,
Okay.
PBX is typically the proxies. Another name is PBX. They use this PBX terminology from your telephone things, because in the telephone world they used to have this PBX. Now they actually call the proxies as the PBX in IP world.
Let's say, okay, it's not a software like you
It is
have to
also a
install a
software. All these
UIP
bloody
software.
things are software. They have to understand SIP protocol messages, and they have to, on the basis of it, it have to forward it. For example, what kind of a protocol SIP is? SIP is basically called as a application level protocol. It is not a network level protocol. It is application level protocol. What is the meaning of network level, application level protocol differences? We have already learned one application level protocol, which is diameter. What is the difference between diameter and SIP? SIP also behaves the same way. SIP, the guy who is originating the SIP voice call, he doesn't know the destination computer's IP address or destination VoIP device's IP address. What does he do? It will simply include this guy's ID here as the SIP ID, the destination ID, and it will send the SIP call details to the proxy. Source IP address is your computer. Destination IP address is your proxy's IP address, is the destination. This guy's IP address will be the destination. Once IP packet reaches here, it will open the SIP packets from inside, and then it will start forwarding the SIP messages to the next proxy. It will be forwarding it to next proxy. How it will forward it? It will find out where the incoming proxy is by using the services from DNS. It will find out that IP address of the inbound proxy, and then it will forward it to that guy. Hey, this is what it is. It'll be doing that job. And then we'll be sending this inbound proxy to the uh, here by finding out the IP address. So how many times we are changing IP address? Let us look into it. When on this path, from here to here, the SIP voice call details will be sent by keeping this guy as the source IP address. This is the destination IP address. Once this guy finds out this other company's incoming proxy IP address, again this guy will start forwarding the same SIP message to this fellow, with the source IP address being the outbound proxy and destination IP address being this inbound proxy. Once inbound proxy, by finding the IP address of the terminating user agent by communicating with the register. Once you get to know the IP address, source IP address is going to be the inbound proxy, and destination IP address is going to be this guys. So we are changing IP address continuously here. It is called as application level routing. It is not a network level routing. So all the components in the middle need to understand the SIP protocol, whether they are present in a separate hardware device, or whether they are installed on a single computer itself. The software is installed. It doesn't matter. I can actually download some proxy softwares and install it. So there are a lot of SIP proxy softwares available. When you install it on your computer also can be acting as a PBX or a proxy, and it will be routing your SIP calls. So we can make your computer also can work, because here anything to be called as a proxy, it must be having the understanding of SIP protocol stacks, and it must be having the understanding of the SIP proxy mechanisms. If you install any such software on an existing computer, or if you keep that software into a separate hardware, it doesn't matter, we can still call it as a proxy. Any other questions? Are still having any more questions?
Sir,
Yeah.
sir, if this is related to like specific VoIP devices, I mean the phones and the services that can be installed in the specific device PCs, then
Hmm.
how it is related to the phones that we are using in the using the IMS network that calls we are making?
That's a good question. uh, all your operator environments also, when they have installed IMS environment, so their user IDs will become at the rate of imsnetwork.com. Reliance Jio user will become, for example, whatever the number that you get from your Reliance Jio, that number at the rate of reliancejionetwork.com, it will become a SIP user ID. So whatever the IMS network that your Reliance Jio operator is maintaining, that network is your VoIP SIP environment. That is just like Wipro.com environment, or Infosys.com environment, or a TCS.com environment, or a Microsoft.com environment. Just like that, it is a Geo.com environment, that IMS network.
Okay, so
Understanding?
whatever the calls we are making using
Yeah.
IMS network, that will be using the SIP protocol
Yes, yes.
for
We'll
the
be making
communication.
SIP calls, because with only SIP calls, you are allowed to make the calls from one network operator to another network operator. With cross platform calls you can make only if you use SIP. If you stick to any private application like WhatsApp or anything else, you cannot make the cross platform calls. But for example, if you take old your telephone network like GSM network, you can make a call from Airtel network to Vodafone network, Airtel to Idea, Airtel to BSNL. Any network you can make a call to. So that's called as cross-platform. Any user can make a call to any other user, irrespective of to which operators they belong to, because it's all integrated in the ISDN. They wanted to have such kind of environment, and this organization called as IEEE, and they have told that the companies who are implementing their own private VoIP environments, if they follow these SIP rules, then we can integrate those environments together to form a worldwide SIP architecture of thousands of companies together, and we can make the calls from any company network to any company network, so it will become cross platform. But in order to make this cross platform work, you cannot be using a different protocol in every network. We should be using an unified protocol, or we should be using a common protocol across the path, and common rules must be followed inside this protocol. What is that protocol? SIP. So they're deriving that all the rules that the company should follow in this integrated environment must be as per the SIP rules.
Yeah, got it, sir. So one more thing.
So,
Yes. Go ahead, any one of you.
Yeah, so sir, if this is like the company, in case of companies,
Hmm.
like to make the calls, calls,
Hmm.
why so much is required? For normal voice calls, they can use the landlines, and for video calls, they can use any secure video call apps.
Hmm. The
Why
advantage
this IP
is
calls?
the advantage of these SIP calls is the amount of services that we can integrate on these VoIP calls and everything is not possible on the normal landline phones. The reason is on normal landline phones, you will be having maximum three or four services like call hold, or you can make a call to one person, and you can may want to make a group call, etc. So it will become very difficult to do things like call transfer and these kind of stuff on your landline phones, because those kind of features are not so much implemented in the traditional networks, in the ISDN network. But in the VoIP environment, you can integrate a lot of services on top of the SIP. Thousands and thousands of different services we can implement on SIP, even including file transfer. You can do various multimedia activities by using the same CP environment. So this is wide variety of services we can integrate on VoIP environment. That is why this is preferred instead of going for your traditional landline phones. The amount of features that we can implement. Is that clear? Is that understood? All of you? Okay. Rahul, you are asking some question.
Sir, my question is, suppose having SIP protocol or any operator having IMS implementation, and
We'll
that
go to
user is making a VoIP call to.
Please wait for
Hello?
IMS. Hello. Please wait for IMS. We'll study IMS for the next few days. Don't have to worry about IMS now. Just stick to this SIP part. First, let us learn the general SIP between the computers. Then we go to IMS part. Okay.
Okay.
At
Okay.
that time, you can ask all your IMS related doubts. So we'll be studying that thoroughly. How the IMS calls will be made, etc., etc.
Hello?
Ronak, I'm not getting anything from your side. You trying to ask any question
Sir,
or something? Yeah.
sir, now
Yeah.
I'm audible.
Little bit.
Sir, my question is that every call is a SIP call or only call on data is SIP call? Like when we are calling landline to landline, is it SIP call or
Landline to landline means which landline you are talking about? Old PST and landline phones?
sir?
No, old PST and landline phones are not VoIP calls. If you, I don't know whether you are talking in terms of LTE network or not. I don't know that part yet. I'm just imagining that you are talking about old landline phone to old landline phone. If you are making a call from landline phone to landline phone, it is never a VoIP SIP call. It is a traditional PSTN network call.
That means call on LT is SIP call.
Yes, every call on LTE is a SIP call except you are making any private environment calls. For example, if you are making a WhatsApp call, it is not a SIP call. It is called as a WhatsApp private operator call. If you are making a call on Facebook Messenger, it is not a SIP call. If you are making a call on Google to Google, it is not a SIP call. Google Duo or whatever the app that you are using. If you are making a call by using Skype, it is not a SIP call. It is using Skype's private application protocol for communicating with the Skype server. That is the private VoIP environments I talked about. But if you are making any IMS calls in by being in LTE network, that is going to be called as a SIP call. That is going to be a SIP and IMS based call. And if you make any private calls to private operator environments like WhatsApp, it is not SIP. It is not be called as SIP calls. It is VoIP calls, but they are not SIP calls.
That means, sir, VoLTE is the SIP call.
VoLT is a SIP call, yes. Segregation is very simple. If you send the data, voice data on IP network anytime, it's called as a VoIP call. In VoIP, we have two segregations. The private networks, private VoIP solutions, which are like with restricted only to that private environment, like WhatsApp, etc. It look like this. There will be a centralized server. There are no proxies, nothing. Everybody will be informing their IP address details to centralized server, informing them what this is my IP address, this is my IP address, and that one single guy will be helping you out to make the call. For example, if this fellow wanted to make a WhatsApp call to this fellow or this fellow, you will be sending that WhatsApp call information here, and that call details will go here, like that. It is a single two-step solution, one step and second step, that's it. You will be performing not by using SIP protocol. What protocol they will use, they won't reveal it. WhatsApp will be using their own protocol, Skype will be using their own protocol, etc. But the other VoIP calls are SIP based calls. Okay, now again in SIP based calls there are two types of calls that we will have. SIP traditional landline phones and SIP-based phones and SIP-based computers will be there with SIP applications, just like the application I have showed you earlier. Those are pure SIP environments. But we use the same SIP solution in our telecom environments also for IMS. This part we need to introduce. We will introduce that IMS part in this subsection.
Sir, VoLT call means VoIP call, is it, or a different call?
Every VoLT call is a VoIP call. Okay. I don't know why you guys are confusing. I never have confused any other batch like this with in terms of explanation. Somehow this whole thing is confused. Okay, read this statement. Package voice data into IP packets by adding the destination IP address. Send it to the destination. It is called as a VoIP call. So even if you pack the voice data into IP packet, in any scenario, it is a VoIP call. Voice data into IP packet. If you are using WhatsApp, for example, your WhatsApp application will listen to your voice, convert into digital information. If the digital information is packed into a IP packet with the source IP address being your mobile phone, destination IP address being your friend's mobile phone, and this is called as a VoIP as well, because voice is traveling with the help of IP technology, it will be termed as VoIP. So if you pack voice data into IP packet, it is VoIP, which calls won't be part of VoIP. Your traditional landline to landline phones, in PSTN, public switched telephone network, the first one we have discussed, the very first class that we have discussed, those calls are not going to be called as VoIP calls, because the voice data, we won't be packing it into IP packets. Instead, PSTN uses some bloody mechanism called as circuit switching. Similarly, if you are making the calls in the PLMN, like in GSM network or in UMTS network, you are making a call from one mobile phone to other mobile phone in GSM or UMTS, CS calls I am talking about. So the CS calls also will be made by creating a circuit between the source mobile phone to destination mobile phone without having to use any IP addressing mechanism. We create a circuit. That is why they are called as circuit switched calls. These two things would never be called as VoIP calls. Other than these two things, any bloody calls that are present in the world are VoIP calls. Everything else is a VoIP call except these two mechanisms: landline phone PSTN mechanism, PLMN mechanism. Other than these two things, any other call is a VoIP call. Your WhatsApp call is a VoIP call. Your Facebook Messenger call is a VoIP call. Your Skype call is a VoIP call. You use any of these applications and make the calls. It is VoIP call. Even your Vivo LTE calls also can be called as VoIP calls, because even in the Vivo LTE section, you will be packing your voice data into IP packet. You will be because LTE supports only IP technology, so you have to generate IP packets in Vivo LTE mechanism. Your voice data would be packed into IP packet. Because of that, we can call Vivo LTE calls also or VoIP calls. So every other call is a VoIP call other than these PSTN and PLMN. Is that idea clear? Any more questions on this, or still having any doubts on here? Okay. I don't know why I might have confused so much confusion for you guys. Okay, sorry. Uh, for your understanding, I'm going to take Excel sheet and let us make the things in much easier way. For example, if you take any company, that company will have what SIP components. What are the SIP components that will be present in that company? Let us list them. There can be n number of user agents. Basically, the individual devices. These user agents can be SIP phones. SIP phones means the IP phone that you buy from the market, or the user agents can be soft phones. Soft phones means the SIP yes, protocol that you are installing on your computer. So n number of user agents can be present, either SIP phones or soft phones. Then you definitely will be having one register for that company. What is the duty of register? All these user agents, hello, all these user agents will be registering with one single register in that company. They will be doing the registration. Now, other than this register, what else we need to have in any company's SIP environment? They definitely need to have one proxy, which is for receiving the incoming calls and sending the outgoing calls. So how this whole story works? Let us suppose there is one SIP user agent here, okay, which could be a soft phone. This is a soft phone. This is a SIP phone. Both these guys are registered with a register, and they have explained their IP addresses, and they also know who is acting as a proxy. So this component is acting as a proxy. Now, for example, if this guy making a call to this fellow, let us suppose, the call details will go to the proxy. This proxy understands that, okay, this guy is called as Ram at the rate of company1.com. This guy is Beam at the rate of company1.com. Once this guy proxy finds out that, hey, I am responsible for company1.com, and this guy is trying to make a call to a user who is also present in company1. What do I need to do? I need to simply go and ask the register, get the IP address information, forward the call to this fellow. Job is done, dusted, finished. So your local proxy itself has helped the call forwarding. We never need to forward this anywhere. So this is one story. The second story about it here. What is the second story? The same guy, we have rom at the rate of company1.com, beam at the rate of company1.com. Both of them have been registered with the registration server, and they also are logically connected to your proxy. They can communicate with the proxy. Let us suppose this guy is making a call to, um, you know, um, somebody else at the rate of company2.com. So the moment it is company2.com, the details will be available in the SIP message. This proxy sees that, hey, this guy is making a call to company2.com user, some user X, doesn't matter who is that. This proxy will say, I need to forward the call to company2.com. I will go and consult the DNS server, ask the DNS server what is the IP address of company2.com proxy. You forward the call to company2.com incoming proxy. So this is the incoming proxy for company2.com. Once this guy gets the incoming call, he says that, okay, this guy is making a call to user X. I will find out what is the user X IP address by talking to my own local register, company2.com register. So if there are lot of computers here, all these computers would have already registered their IP addresses with this register. Once company2.com proxy asks this guy IP address, he will reply back and provide the IP address. With the help of it, the SIP call will be destined to that particular component, that particular user. It will be destined there. Are you guys understanding this? It is a pretty simple environment. It is the integration of multiple thousands of networks. All telecom operators available in VoIP call. We talk about telecom operators later. First, we study the SIP environment with computers and SIP phones. We study that part first. I will come to VoLTE IMS part a little later because you guys are confusing with the telecom part. Ignore telecom part while understanding the SIP architecture right now. Just understand there is a SIP phone which looks like a landline phone, or a soft phone which looks like the soft phone I have just showed you, the soft phone software I have showed you. So the X-Lite software that I have showed you, this is soft phone. This is soft phone developed by a company called as X-Lite. Sorry, the software name is X-Lite, developed by a company called as Counterpath. Okay, we come back here. Now, if any company wanted to bring up their VoIP environment, what do they need to do? If they buy the VoIP phones, will that be enough? If they buy the SIP phones, will that be enough? Answer is no. They have to pay some money to IANA, get their domain registered. They have to do that task. So, for example, if tomorrow you are building a new company, for example, let us suppose. Now, that company, you estimated that there are going to be 500 employees. You wanted to implement the VoIP SIP environments because cost is less. And on top of it, the services we can have are enormous number of services we can have on SIP phones when you compare with the traditional phones. So obviously, you decide to implement a SIP network. There are two choices for you. One is you can go and get the SIP services from an existing operator, like you can go and take these services from Airtel. When you take it from Airtel, all your IDs will be airtel.com. All your employees' IDs will be airtel.com. It will not be your company's IDs, it will be airtel.com IDs. But if you decided that, hey, you don't want to get these services from Airtel, you want to get your own domain name, even though it is a little investment, you go and pay that money to IANA and get the domain name registered. If your company is called as company XYZ tomorrow, so you will be calling it as companyxyz.com. So that is your domain name. You will do the registration with it. Now, all your employees, every employee will have a username which look like a mail address or something like that. Your first name dot second name at the rate of companyxyz.com. That will become your SIP ID. Now, anybody in the world can make from any other SIP device can make a call to your company. How that is possible? Once the registration is completed, your company will be installing a proxy in your company's building, a SIP proxy. That SIP proxy will have an IP address. That IP address details will be provided to worldwide DNS servers. We will store that information into DNS registration servers. For example, a employee from Wipro is trying to make a call to you. Once you try to make a call, the call will be routed to your proxy because already a domain is registered and the call is now arriving at your proxy. Your proxy will find out your computer's IP address by talking to the local register and then route the SIP call to your device, your computer or your SIP phone. It will be routing the calls to that and you will get that incoming call. You will pick it up and you will start speaking. Are you understanding this architecture? It is very simple. Anybody can bring a SIP environment whenever they want. You just need to purchase the domain and start integrating your services, and you can have as many number of users you want, and you can implement as many number of devices you want. User agents can be any number of user agents. Doesn't matter. But you need to register that domain name with IANA by paying some money for that. Is that clear? I talk about telecom part later. Well, just come to that in the coming up sessions. Okay. What are these yellow lines and what is this aqua color line? To send the SIP messages, because we don't know the IP address of the destination component, we have to take the help of the proxies to forward the call. So SIP messages are traveling in this path. But whereas once at least one time communication happens between these two components, one time communication, full-fledged, like what do we call it is like um, to and fro communication is completed. Now these two guys will get to know each other's IP address. Once they get to know each other's IP address, they can exchange further SIP messages directly without involving the SIP proxies, as they have already found out each other's IP address. Because at the starting they don't know the other component's IP address. You are making the SIP call on the basis of a SIP ID, and you are sending the details to the proxy. You are not sending the information to the other device on the basis of IP address. It is application level routing that we are implementing here. Even after the SIP session is established, user data can also be exchanged directly, as each of these guys know each other's IP address. They can exchange the user traffic also directly. RTP here represents the user traffic because your voice data will be sent on RTP UDP IP protocol stack. It will be sent on. Okay, so this picture actually here, the shape is a technical meaning in SIP. Sending the SIP messages to your outbound proxy to the other company's incoming proxy to the end user. This particular shape that we see, and after the one communication happened, and whatever the user data that is traveling directly from this device to the other device is actually forming some kind of a shape. This is called as a SIP trapezoid. The shape mathematically is called as a trapezoid. So it typically will be an interview question. So they will ask you what is the meaning of SIP trapezoid. So answer is sending the SIP signaling messages with the help of the proxies, outgoing, incoming proxies, and sending the user data directly between user agent client and user agent server. The shape of this signaling plus the user data, if you join the coordinates, it looks like a mathematical shape called as trapezoid. That's what they call as SIP trapezoid. Just one non-technical word thrown at it to make the things little complex. That's it, but nothing much on that. Okay, for example, this is the other thing I'm talking about. If you are making a call to a mobile user or a SIP user who is present in the same domain, same network as you, what do you do? When you send a SIP message to the proxy, which is outgoing proxy, that outgoing proxy himself will be acting as the incoming proxy as well, because both the guys network name is the same at the rate of airtel.com, for example. Their network ID is the same, says their SIP network domain is the same. So then this incoming proxy, outgoing proxy will be acting as incoming proxy, and it will go and request the register what is the IP address of this fellow. After finding the IP address, the call will be routed to the end unit, and then you will be establishing the user traffic directly. Okay, so it could be in a single company. This could be the environment when you don't have a second network that is present. But it all depends on whether you are making a call to this from the same network system to the same network system or to a different network system. Okay. So what is this SIP protocol is all about? How it works? Um, More and more details will be known to us in SIP once we started studying the SIP call flows and etc. But first we introduce the SIP protocol itself. It is a text-based, very heavy protocol, and the data that is present in the SIP protocol is represented in the text-based format, just like a text file, just like that. So it looks like English. The SIP protocol looks like English. There won't be literally no difference between English and SIP. It is going to use application level routing. It is not network level routing protocol, just like diameter protocol, which doesn't use network level routing but application level routing. SIP doesn't provide any services on its own, but SIP will provide all the required primitives or the supporting system it has built to implement different services. Um, that means SIP is not designed to provide any services other than the six services that we have discussed earlier, like identifying the IP address, like those six services, the establishing the session, maintaining the session, terminating the session. Other than those basic activities, SIP is not designed to implement the services on its own, like call holding or maybe all those kind of activities. You need to you have the primitives to implement those services. Traditional SIP doesn't have those services directly implemented. For example, SIP can carry third-party multimedia parameters for your multimedia session. You can establish a multimedia session and you can exchange that multimedia session is using what kind of a quality of service, etc. For a third-party application also by using SIP. For example, here in this case, we can have a protocol called as SDP to send these multimedia properties, multimedia parameters. So we can have that capability for SIP. Okay, what is the meaning of it? We will find out. So how many types of messages we have in SIP? We have two kinds of messages in SIP: request and response. Request is initiated by client and response is the one originated from the server. So who is client, who is server? The SIP call initiator or SIP session initiator is called as the client, and SIP session receiver is called as a server. It could be just SIP devices, but one device would be typically termed as client and other device would be termed as server. That is the idea. Request and response that we have. So what is the generic message structure for SIP? What details will be present inside the SIP messages? It will have something called as a start line, which represent starting line, and then it will have something called as a message header, followed by these two things. You have some CRLF, whatever it is, followed by that we have message body. So this is the typical structure of the SIP message. What we need to identify one by one. So it is a long story about this message structure. We will be looking into those details and studying that part to understand SIP in a perfect way. So totally how many pieces? Start line, message header, CRLF, and message body. But this message body is kept inside square braces represents this is optional. Maybe there, may not be there. This message body. What is that message body? We don't know yet. But these are the pieces. Only thing we know is this is optional. Rest of the things will be there. Start line will be there. Message header will be there. CRLF would be there. Okay. Then what is this start line? The start line we are going to have will explain whether the SIP message is a request message or a response message. Request line or status line. Request line is the request related information. Status line is the response related information which is coming from the other side. So we are going to have one of these two things, request line or status line. Okay. So this is the total sample structure that we have in SIP, requests and responses. Okay.
Sir,
Yeah.
star icon in message header means mandatory.
Which one?
Star icon in that message header.
That star icon represents something basically. What is it? I'll tell you. That star will
Okay.
represent something. It is not like it is mandatory. What is that message header? I have not told you what is that message header. That message header is a lot of message header parameters will be there inside it. So, what is the meaning of that star and how that goes? How does that work out? We will see that part. These are the technical parts inside a SIP message. We will be looking into these technical parts one by one. Okay. Now, which one we are learning now about? Today we'll try to study the request line part. What is this request line? What will be it containing? SIP request line. You will have something called as a method name of the method. So all the procedures in SIP are called as methods. You will have the name of the method. SP stands for a space. It is a literal space. Request URI, whatever it is. I will introduce what is that. Space. SIP version. After that, we have something called as CRLF, whatever it is. We don't know what that CRLF is yet. We will identify. First, one by one. First, what is the method name? The methods are SIP request methods. How many methods we have in SIP? Lot of methods. For each method is for different purposes. For example, the methods that are derived in these documents, um, each method is for a different purpose. For example, register method. In the base document that we are studying 3261, we have 6 methods. Register method. To register with the location service, to report your IP address, we use this register method. Invite method. To initiate a SIP session, you will be using invite method. In order to acknowledge um, the response received from the other side, if you send a invite, you are going to receive a response for that. For you are going to confirm that response with the acknowledgement. Okay, you will be reporting back, hey, I received your response message. I am acknowledging that response message. So it is like the third message in your structure. What is the third message? You send invite and the other guy is going to send a response For that response, you are going to report back an acknowledgement. So this invite method is here, and this acknowledgement method is here. This part is considered as response. It won't come under request line. The second one is the response part. But we are right now studying the request line. These are the request methods, not response things. Okay. Cancel is to cancel a pending request. You have initiated a request which is still pending, you're canceling that. By is to terminate a dialogue or a session. To terminate your session, we use by SIP session termination. And options is to query the other SIP component and find out what are its SIP capabilities. Like for example, you can query the other SIP endpoint and find out what and all different methods the other SIP endpoint supports. You can uh, you can request for that kind of information. That is options. Uh, Asking for the other components detail. For example, you can ask the other guy, "Hey, I support subscribe and notify methods. Do you support these methods also?" You can tell. You can use options method for finding that out. Okay. Now there is something called as a PRAC, which stands for provisional acknowledgement. PR is provisional, ACK is acknowledgement, provisional acknowledgement. Now, if you generate a invite method, typically we might be receiving a final response. If you receive a final response, if you are acknowledging that final response, we initiate the acknowledgement procedure. But if you receive a provisional response from the other side, so now from these two points we can understand that responses are two types: final responses and provisional responses. Whatever they are, I'll introduce them. But if you are acknowledging final responses, we will call it as acknowledge. And if you are acknowledging provisional responses, we will call it as PRAC or PRAC. Okay, so or sometimes it will be called as PRAC. So there are a lot of different names we can use it. So that way, provisional acknowledgement for provisional responses. Of course, we need to understand what the hell is this final response, what the hell is this provisional response, what is the difference. That part we'll understand in the response part. But right now we are studying the request line. Okay, then there is something called as update. Update is to modify the session without changing the state of the dialogue. Whatever it is, we are making some modifications to your existing session. Whatever is this dialogue, I haven't explained you anything related to the dialogue. I will at the later stage, but for that purpose, we use this update procedure. Message to transport the text messages by using SIP, we use message method. Refer if you are doing call transfers or if you are referring one guy to the other guy, etc., you will be using refer method. Okay, so to um, provide the reference. And publish. um, Publish is to publish events to a notification server that hey, so and so event is going to get triggered right now. I'm reporting it to you. Whoever have subscribed to that notifications, you please send a notify. So these three things are actually interlinked. So there is a notification server, one server reporting to notification server that there is a event getting triggered right now on my side. Once you tell this to him, the, already some clients here must have communicated with this notification server and told him, hey, if so and so event starts with this component, report us. They might have already subscribed for that service, the notifications. When this event server reported that the event is now happening, immediately this guy will go and send a message to these fellows called as notify. Hey, I'm notifying you that there is so and so event is getting triggered. So right now, because you have subscribed for knowing this information, I am reporting it with the help of the notify. So like what are those things we don't know yet. That this is all general information related to SIP. We will be looking into the deeper details on that. Info. In the mid of the session, if you wanted to um, like uh, without changing the session state, if you wanted to make any modifications to your session related things, that is called as info. Send mid session information that might not change the session state. What is the meaning of a session state? And what is the meaning of not changing the session state? We'll have to find out. But in the mid of the session, we can initiate this info method. There are a lot more methods. These are only from some number of documents that are there on SIP. Some more methods are there in SIP, which I have excluded from here because it become too much for learning. But I will send you the documents. You can read through those additional new methods that are getting introduced in the recent past. So you can do that. But we will learn about all these methods and what is the use of those methods. That is the name of the method that comes here. The name, as it is, the name itself will be there. It is not, method is not one parameter with 8 bits or 16 bits. It will contain exactly the name itself as it is in the English characters, in the form of English characters, because SIP is a text-based protocol. So after the name of the method, you will have a space. Okay, after the space, what you will have? Something called as a request URI. What is this request URI? Request URI is a SIP URI or a SIPs URI, one of the two things, or it can be a telephone URI. If you are making any call to your telephone devices from the SIP network by using gateways, external gateways connecting to ISDN technologies, PSTN or PLMN, then we have to use a telephone URI. SIP URI, SIPs URI, or telephone URI. What is URI? URL stands for Uniform Resource Locator, which we use in HTTP protocol. Every website address is called as a URL. You will be asking what is your company's URL. Same way, SIP user IDs are called as SIP URIs. For example, user x at company1.com is a SIP URI. So the to whom you are initiating the session, that user's ID, the SIP user ID, will be present in the request line in the form of a request URI. That can be a SIP URI or a SIPs URI. What is the meaning of SIP URI and SIPs URI? In case of a SIP URI, security is not enabled, encryption is not enabled. SIPs represent session initiation protocol secured, where your presentation layer is there, present, working, and you are having additional security with the presentation layer mechanism. So that is the SIPs URI part. And then we have telephone URI, which look like a telephone number. So whatever the person you with whom you are like trying to make a SIP session, that guy's ID will be present in the SIP URI part here. And then space, a literal space will be there. After that, you have SIP version. SIP version is SIP version 2.0 we are having. So it will have SIP slash 2.0. That information will be there, SIP 2.0. Because right now we are operating on SIP version 2. Followed by that, we have CRLF. What is CRLF stands for? Stands for carriage return line feed. In from ASCII point of view or UTF-8 point of view, carriage return value is 13 in the ASCII code. Line feed value is 10. So there will be 2 bytes of information. CRLF is whose value is 13 converted into 8 bits, 10 converted into 8 bits. Every character is in fact 8 bits in SIP protocol. But here CRLF is 2 characters. One is carriage return and the other one is line feed, carriage return line feed. This terminology carriage return line feed came from the old word from your what do we call it, typing machines. Once the typing machine moves from left to right to left, once it types up to the last character possible on the page. If the carriage returns to the original position, one line will be fed to your page that represents the next line. So basically, carriage return line feed represents the next line. That means after the request line is completed, you will be going into the next line for the rest of the information. So the CRLF represents that this is the end of your request line, which is containing method space request URI space SIP version, then followed by CRLF. Because it is a text-based protocol, everything is designed in the form of a text. everything is ABCDs and textual information that is present in SIP. We'll understand what is the meaning of that once we start studying the log analysis on SIP protocols, etc. So we'll be able to see that part. We'll look into it. All right. Great. So that is the request line. Now, which part we have done and which part we haven't yet? We need to complete two parts. We need to understand request line and also as well as status line. Today we have completed up to request line. Tomorrow we see status line and what is message header, what is message body, CRLF, etc. The other part of it we will introduce in our tomorrow's class and continue with the protocol and start learning the SIP protocol and SIP call flows. We go into it one by one.